We're talking about solving systems of equations, and we want to graph and solve systems of linear equations in two variables. So when we do that, we want to graph all the equations on the same coordinate axis and then check for intersections. The issue with these two are we don't have these in y equals mx plus b form, so they're going to be tough to graph. So the first thing I'm going to do is solve each equation to get it in y equals mx plus b. So 2x is equal to -1 minus y. And so what I can do is I can add y to both sides, because I just like y being on the left. These are not like terms, so I cannot add them together. So this is 2x plus y is equal to -1. And then we want to subtract 2x from both sides. And then we get y equals -2x minus 1. So that is now in a form that we can graph. And we start with -1. And then our slope is down 2 to the right 1, down 2 to the right 1. And we can do that up 2, back 1, up 2, back 1, up 2, back 1. And then we can draw the line that connects those dots. So that was, whoops, I just drew a line through there. That was our blue equation there. And we have to do the same thing for our bottom equation. So we have -x minus 1/2 y minus 1/2 is equal to 0. So we want to get y by itself, and the y is already on the left-hand side. So I can add x to both sides. And x and x cancel. And so we're left with -1/2 y minus 1/2 is equal to x. Then we can add 1/2 to both sides. And then we get -1/2 y is equal to x plus 1/2. And now we have multiplication over here on the left. We have -1/2 times y. We could divide by 1/2, or what's a lot of times simpler to do is to multiply by the reciprocal. So we're going to multiply by 2/1, -2/1 on both sides of the equation. So the -2 cancels the -1/2, and on the left-hand side, we're left with just y. And then on the right-hand side, this is actually -2, so we have to distribute that into our parentheses here. So then we get -2x, and -2 times 1/2 is just -1. So in that case, as we look at that graph there, we see that our equations are exactly the same. They have the same slope, and they have the same y-intercept. So they're the exact same line. So we can go to graph it just to show that they have the overlap. So they are the same line. So over here we can put same line, and those are infinite solutions. We look at the same thing for number 18. Again, we want to get y equals mx plus b. So top equation here, we have -3 plus 2x plus y equals 0. So we can add 3. And then we get 2x plus y is equal to 3. And subtract 2x. And then we get y is equal to -2x plus 3. And then we can graph this equation because now it's in y equals mx plus b. So we go up to positive 3, and then we go down 2 over 1, down 2 over 1, down 2 over 1, down 2 over 1, and then we can go up to left 1 as well. And we can draw that line. Then we have one more to check. So we have negative 3y equals negative 9 plus 6x. So we can divide by negative 3 to get y by itself. And we get y equals negative divided by negative is positive, and 9 divided by 3 is 3, and 6 divided by negative 2 is negative 2x. Now I want to write this in y equals mx plus b form, so I'm just going to switch these last two terms. So y equals negative 2x plus 3. And then we can see that we have the same slope and the same y-intercept. So again, these are the same lines. These are the same lines, so they overlap and have infinite solutions.